Hello, and welcome to this edition of Stats Chats, where you're going to be talking about analysis of variance. Analysis of variance can be thought of as sort of an extension of a t-test. So if you think back to the t-test, remember in a t-test we look at two groups and we look for differences between the average or the mean within the two groups. So it's a way of comparing, say, a treatment group and a control group, or a pre-test and a post-test. But what happens if you want to look at more than two groups? Like maybe you have a CBT group that's getting cognitive behavioral therapy for treatment. Maybe you have another group that's a control group that's maybe on a waiting list to receive treatment, and then you have another group that's receiving, attachment related treatment, and so you want to compare the three different treatment modalities. Then you might want to look at something, you might want to use an Anova, because an analysis of variance or Anova lets you look at the differences between more than two groups. So experiment-wise error rate also comes into the picture here, because if we were going to just do a lot of t-tests to examine the difference between the treatment and control, between treatment 1 and 2, then that increases the likelihood of experiment-wise error when people are testing multiple hypotheses and just doing test after test. So you can use things like the Bonferroni correction, but we're trying to get away from doing multiple analyses when one analysis can handle it all at once. So when you test multiple hypotheses or multiple t-tests, with one statistical test, you reduce experiment-wise error. So that's where the Anova really comes in. And you can use Anova to reduce the amount of error. So how do you conduct an Anova in SPSS? Well, first of all, let's formulate a research question. For the purposes of this data, in this example, we're going to look at data from an empathy training, where psychologists and counselors that are in training had an opportunity to participate in an 8-week-long online training to help increase their levels of empathy towards themselves, empathy towards others, their sense of self-compassion, and they went through 8 research-based training modules to help them through this process. So the research question here was looking at that data and asking, is there a statistically significant difference between attachment-related anxiety groups, so high amounts of attachment-related anxiety, moderate and low, and their level of emotionality on the trait emotional intelligence questionnaire. So I believe the emotionality includes trait empathy. I'd have to double check that, but there's different emotionality is one of the 4 factors that comprises trait-based emotional intelligence. So we're looking at, based on what anxiety group an individual is in, if this is creating a statistically significant difference in terms of whether they have high, moderate, or low anxiety when it comes to this dimension of their emotional intelligence called emotionality. Or another way to say this research question is there a difference in the emotionality factor on the emotional intelligence assessment across anxiety groups from low, moderate to high? So we want to identify either 3 levels of a variable or 3 time periods, because remember the Anova is going beyond the t-test to compare more than 2 groups or more than 2 levels. Okay, so we looked at first a histogram to visualize the distribution of attachment-related anxiety scores and to inform our categorization with frequency count. So as you can see, this is the distribution of scores. You can see, anywhere from 1 to just before 6, it looks like. We see the mean is 2.48, the standard deviation is 1.09, and there was an N of 50 for this distribution. And then on the right, you can see a frequency table that kind of shows how the different values were distributed in terms of attachment-related anxiety, from as low as a 1 to as high as it looks like a 3 at the time of post-test for the total 50. So that means for both the treatment group and the control group. Now remember, the control group did not receive the treatment, so we want to keep that in mind when we're looking at post-attachment related anxiety. We're just looking at a snapshot of that anxiety level at that point in time. So we're defining the scale between three groups of people with low, moderate, and high levels of anxiety. And then we're going to be looking at their level of attachment related anxiety in terms of that scale from 1 to 7. 1 to 2 is considered low, 2.1 to 3.5 was considered moderate attachment related anxiety, and 3.6 to the top of the scale was considered high. So in order to do this, we first had to transform the variable and recode it into different variables. So if you open SPSS to do that, you can go to transform, and then you can click on recode into different variables to then transform and recode into different variables. And as you can see, it says recode into different variables. We took post-related attachment anxiety and changed it to 3 levels of post-attachment related anxiety for the output name there. And then once you click on change and you go in here, we have to indicate the ranges, right? So we looked at, the lowest through, 2, and then we did another range from 2.1 to 3.5, and then we did another range from 3.5 to the highest level. So we were able to transform that variable. And then after we have that transformed 3-level variable to use for our Anova, we can go ahead and run the statistical analysis in SPSS. So to do that, we take our mouse and click on an Analyze, and then compare means, and then you'll see a new drop-down menu pop up, and then we want to click on one-way Anova. Then we need to identify our dependent variables and our independent variables. And as you can see, you click on one of these variables, click on the arrow, and you move it right over. And our factor is the 3-level post ECR anxiety. So the 3 levels of anxiety. And for dependent variable in this situation, we chose to look at trait emotional intelligence, specifically emotionality at the time of post-test for that. Then options to select, we selected descriptive statistics, homogeneity of variance, Brown's, some of these were already selected, so that was okay. We click continue. We want to make sure descriptives is selected there. Then we also click on post hoc, because if we do find statistically significant differences, the post hoc analysis helps us to pinpoint those. So we want to select Tukey's for our post hoc and click continue. So our SPSS output, one of the first tables we look at is the Anova. And so with the Anova, we can see, okay, wow, the significance level here, you'll see in the last column, 0.002. This is less than 0.05. So what does this mean? Well, that we do have a statistically significant difference between groups. But how do we know where the difference lies? Well, that's where we want to do a little bit more analyses. Here we can see in this Anova table that the significance, now with that one, hold on, let me go back. So with this one, we were looking at the variables of trait emotional intelligence, right, between groups and within. And if we go back to where we selected the variables, let's see. We have trait emotional intelligence emotionality as a dependent variable, then 3 levels of attachment related anxiety as an independent variable. So here we have trait emotional intelligence emotionality as a dependent variable. We have that that's statistically significant. Now, here's another example looking at post-attachment related anxiety, and the significance level here with the Anova output is 0.07. So if it's not less than 0.05, we would conclude that maybe this isn't, we wouldn't necessarily go forward with doing a post hoc analysis in Tukey's HSD because we're not seeing that statistically significant difference. So let's look at a different example that might give us that output just to explore it more. So let's look at attachment-related anxiety at the time of post-test as our dependent variable, and the three categories of emotional intelligence, high, low, moderate, as our factor. So when we do this, we want to make sure we select Tukey's for our post-hoc analysis. And then here we find there was no statistically significant difference between emotional intelligence categories based on attachment-related anxiety. Okay, so that's an interesting finding, but we look at the significance levels, it's all well above 0.05. So we might want to look at something else, right? Well, let's look at self-compassion or self-empathy, right? Between people who had a high, a moderate, or a low level of emotional intelligence at the time of pretest, right? Before they even started the treatment. Was there any difference in their self-compassion? So here we find this is statistically significant at the p is less than 0.001 level. So you could say between group 1, low emotional intelligence, and group 3, which is high emotional intelligence, there is a statistically significant difference in self-compassion at the p is less than 0.001 level. So that's exciting to find out. And when we look at this multiple comparisons table, Tukey's HSD output, we can see in the significance column that there is a statistically significant difference between each of these groups. So that's very exciting to see. Next, we want to check the means. So in order to look at the means, we have to make sure in the options for our Anova, we selected descriptives. So if we select descriptives and go through those same steps with Anova and click OK, then we receive this output. So we can see the average or the mean self-compassion score for each of these different levels of emotional intelligence, right? So as we can see, 3, the highest level of EI, also has the highest average self-compassion, and it seems to increase with each group. So let's go over an APA-style checklist. So now you've conducted the Anova, you've conducted the post-hoc analysis, you've run your descriptive statistics, you have all your good SPSS output. Now it's time to write things up. So what do you need? First, you need to find the F value that's found in the Anova table. So as we can look at this table over to the right, and you can see that the F value here is 11.551. Okay, then we also need the significance value found in the Anova table. So we see where that F is in that first table, the second to last column, F is 11.551. Right next to that, to the right, there's a significance level, which is less than 0.001. So now we have our significance value found and our F value. We also want the means of each group. So we might have to run descriptives to find this. So I think in this example, we did not include those. So we had to go back and select that under options and run it again, which I'll show you in a later slide. But, so if you forget or don't see it, that's no problem. You just analyze it again and make sure to check that box. One thing that's important to remember too is whenever you report a mean, you also want to report the standard deviation, so you can include those values in your output. And also, many journals are now wanting people to include effect size. So with Anova, eta squared is one of the easier effect sizes to calculate. So the equation we use here is sum of squares between groups divided by total sum of squares. And we can find this information in the Anova table from Cohen 1988. And remember, he says there, if your value is 0.01, that's a small effect, 0.06 is a medium effect, and 0.14 is considered a large effect size. So, I should say size. Okay, so because we have 0.334, that would be considered a large effect size. Now remember, we've talked about different effect sizes before. It's important to note that there are effect size calculators out there, so you can convert eta squared to Cohen's d. But most of the time, journals just want you to have an effect size. They don't necessarily specify which one you have to use, unless you're doing a meta-analysis, and Hedges G is recommended there. So what does the APA output example for a one-way ANOVA look like? Well, here's an example. So first we start out explaining what statistical test we used. So we say the researcher conducted a one-way analysis of variance to examine 3 levels of emotional intelligence, EI low, moderate, and high, and to evaluate differences there, in self-compassion based on these emotional intelligence levels. Emotional intelligence was divided into 3 levels based on the 7-point scale of the trait emotional intelligence questionnaire, where low was 1 to 3, moderate was 3.1 to 5, and high was 5.1 to 7. The researchers found a statistically significant difference across all levels of emotional intelligence, and the F ratio was 11.55, and the p-value was less than 0.001. The effect size for the ANOVA was 0.33, indicating it had a large effect, and the post hoc was conducted using Tukey's HSD, and there was a statistically significant difference found in self-compassion between all levels of emotional intelligence. Low emotional intelligence had a mean of 2.69 with a standard deviation of 0.62. Moderate emotional intelligence had a mean self-compassion level of 3.23 with a standard deviation of 0.73. And then high emotional intelligence had a mean of 4.17 with a standard deviation of 0.52. So here they were all statistically significant. However, this isn't always the case. So if one of the groups or levels was not statistically significant, then you would just let the reader know this by saying there was not a statistically significant difference, for example, between group 1 and group 2, or whatever the case may be. Okay. So as a side note, based on the highest emotional intelligence group having the highest self-compassion mean, we started to wonder, okay, is it safe to say that as emotional intelligence goes up, self-compassion goes up? So we said we may want to test whether it's safe to say this. So how do we determine if these variables, if as emotional intelligence increases, self-compassion also increases? Well, we looked at doing a correlation. So here is the Pearson's R correlation output, and you can see that it was statistically significant at the 0.001 level, and the correlation value was 0.746. So remember, 0.7 to 0.9 from Hinkle's table is considered a statistically significant correlation. So we found that there's a statistically significant connection between trait emotional intelligence and self-compassion or self-empathy. All right, so one good practice to practice conducting a one-way ANOVA is to take a variable from a data set, turn it into 3 levels. So for example, in SPSS, we can go to transform, and we can say recode into different variables. And then we can identify a variable that we want to use, and then we can go and we can label it. Once we label it, we can click on change, and we can put in the values and the information, and we can change that to represent what we're interested in looking at. We can conduct a one-way ANOVA by going to Analyze, Compare Means, and then one-way ANOVA. So let me show you that in SPSS. If you go to Analyze, and then you go to Compare Means, and then you go to one-way ANOVA, this is the window you'll see. And we also want to make sure and go to Options and make sure descriptive is selected. That'll allow you to get your means and standard deviations. And then we also want to go to Post Hoc and make sure Tukey's is selected, because, excuse me, my dogs are fighting over their bed. But if Tukey's is selected, then that will give you the Post Hoc output. So we click Continue, and then we click on OK, and then we see the output here. for this analysis. And you can look here at the significance levels, the F value. We can see there is a statistically significant difference here as far as this ANOVA goes. And we can also, we have the information we need in terms of the sum of squares to calculate the effect size. We also have the descriptive statistics to be able to report the means. So we have everything we need here for our APA output. So, but you can pick a variable, turn the variable into 3 levels. So here we use emotional intelligence, high, medium, low. You can use that with attachment-related anxiety. You can use that with self-compassion. But you want to identify an independent variable or predictor variable and see, okay, what are you interested in using to predict a dependent variable? And you can also identify a dependent variable. So for example, one of the ways of measuring empathy, you could look at the interpersonal reactivity index, empathic concern, and try to identify, well, what variables do you think are going to predict empathic concern? Will it be attachment-related anxiety? Like, do you think if people are higher in anxiety, they might have less empathic concern? So you just want to make sure you have some sort of rationale for what you choose, but it can be helpful to identify what your IV is and what your DV is, have a rationale for that as you turn a variable into 3 levels. Then you can conduct a one-way ANOVA, and we just went through that process, and include the SPSS output. Whenever I'm, creating a slide and doing a sample SPSS output, I like to do a screenshot of the outcome information, and then you can use that to interpret the output. You can calculate the effect size using an equation for eta squared, which is the sum of squares between groups divided by the sum of squares total, and then report the results in APA style. And I always encourage students to include at least one peer-reviewed reference to contextualize the results. To say, this is what we found. Other researchers have found X, Y, Z. Perhaps because of what we've seen in the literature, we can make a case for the, attachment-related anxiety, let's say influencing self-compassion, because people that tend to be high in attachment-related anxiety tend to have internal working models that suggest that the self is not worthy of love, whereas people who are very high in self-compassion towards themselves tend to believe that, they're experiencing what's common to humanity and that they're worthy of love and care. So those are some things to keep in mind. So there you have it. That is information about how to conduct an ANOVA. Thank you for taking the time to watch this SPSS tutorial in addition of stats chats. I hope this gives you some concepts to contemplate. Until next time, God's blessings on your work.